The previous two videos briefly introduced the C and C++ programming languages and mentioned that C++ is derived from C. Today, we'll talk about the differences between the two. By the end of this video, I hope you'll have a clear understanding of how to distinguish C from C++. Alright, let's get started. First, in terms of core philosophy, the key difference lies in programming paradigms. C is a procedural language. Think of it as a precision scalpel focused on maximum control and efficiency. C++, on the other hand, is a multi-paradigm language, Swiss Army knife, that maintains performance while providing powerful abstraction and encapsulation features. Procedural programming's core idea is program equals data plus functions. Data is either global or passed into functions, and functions operate on that date like writing a recipe. First do this, then do that. As a result, C heavily relies on global variables and standalone functions. Data and the functions that operate on it are separate. This separation can make large projects messy, with unclear relationships between data and behavior, making reuse and extension difficult. C++, however, supports multiple paradigms, with its core centered on object-oriented programming. In C++'s philosophy, a program equals a collection of objects. Objects bundle together data and the functions that manipulate that data. Key object-oriented programming concepts include class, the blueprint for objects defining data members and member functions. Encapsulation, bundling data and methods together while hiding internal details. Inheritance, creating new classes by reusing features of existing ones. Polymorphism, using virtual functions to allow different implementations of the same interface. This makes C++ code more modular, easier to understand, reusable, and extensible. Plus, object-oriented design aligns better with real-world modeling. You can also intuitively feel the differences through the code displayed on the screen. In C, we can only use structs to simulate objects. There are no concepts of classes or true objects, nor mechanisms like inheritance or polymorphism. In C++, we can define classes to create objects, use constructors and destructors, and take advantage of object-oriented features, making the code easier to extend and maintain. Next, let's look at memory management. C uses manual memory management, relying on functions like malloc, calloc, and realloc to allocate memory and free to release it. This approach is risky. For example, memory leak can occur if free is forgotten, causing the program to consume memory until it crashes. Dangling pointers, where a pointer still points to memory that has already been freed, can cause crashes or corrupt data. Uninitialized or freed pointers, called wild pointers, can lead to unpredictable behavior. C++ adopts a semi-automatic memory management model. Centered around the RAI, resource acquisition, is initialization principle. Memory is allocated with new, invoking the constructor, and released with delete, invoking the destructor. RAI binds the lifecycle of resources like memory, files, or locks to the lifetime of objects. Resources are acquired in the constructor, for example using new or opening a file. When the object is destroyed, the destructor automatically releases those resources, for example, using delete or closing the file. Since C++11, smart pointers have been introduced to encapsulate raw pointers and use destructors for automatic memory release. This significantly reduces memory leaks and dangling pointers. Even when exceptions occur, destructors ensure resources are cleaned up, improving exception safety. In short, C's memory management is like walking a tightrope requiring full concentration from the programmer. C++'s RAI and smart pointers are like safety nets and autopilot, greatly enhancing safety and robustness. Lastly, differences in standard libraries further set the two apart. C's standard library focuses on basic functionalities, found in headers like standard io.h, standard lib.h, string.h, math.h, etc. These libraries are low-level and limited in scope. There are no built-in advanced data structures like dynamic arrays or dictionaries. Developers often have to implement such structures and algorithms themselves or rely on third-party libraries, reducing development efficiency. Even implementing a dynamic array requires manually managing malloc, realloc, and tracking sizes. String operations are error-prone, for example, buffer overflows during string copying. C++ offers a powerful standard template library, STL, which includes containers like vector, list, map, set, string, etc. Algorithms like sort, find, copy, transform, and many others. Iterators, which provide a unified way to traverse elements in containers, akin to smart pointers. STL demonstrates C++'s strength in generic programming through templates, algorithms that work independently of specific data types. For instance, sort can sort integers or custom student objects. STL is highly reusable and ready to use out of the box. It avoids reinventing the wheel, ensures type safety, and compiles to highly efficient machine code, often comparable to handwritten C code. So if C's standard library is like a toolbox with wrenches and screwdrivers, C++ STL is a modern, automated, and highly integrated set of engineering machinery that dramatically boosts development efficiency and code quality. In conclusion, although C and C++ look syntactically similar, there are significant differences that lead to different use cases. C is the cornerstone of system-level programming, widely used in operating systems. For example, 95% of the Linux kernel is written in C. Embedded devices and microcontrollers, where resources are limited and efficiency is critical. Device drivers and other areas where close to hardware and precise control are essential. C++ is the builder of complex systems, widely applied in game development. For example, Unreal Engine's core is in C++. Image processing, for example, OpenCV. Financial computing, for example, high-frequency trading systems. Large-scale software like the Adobe Suite. If your project demands maximum performance, low-level control, or needs to run on resource-constrained environments, C is the best choice. But if your project involves complex business logic, needs scalability, or benefits from object-oriented design to improve development efficiency, C++ is the better option. That's all for this episode. If you want to see more videos like this, please like and subscribe. If there's anything else you're interested in, feel free to leave a comment. Thank you all.